Today in 8th grade Common Core Math, we are going to be learning about Module 1, Lesson 2, multiplication and division of numbers in exponential form. So your objective today is you will be able to use the rules of multiplying and dividing exponents to simplify expressions. So let's review what we learned on our last lesson. We learned that this x is the base. And we learned that this guy over here is called the power. Okay, so this is x to the nth power. We learned that when a base is negative and is raised to an even power, then the answer is going to be positive. We also learned that if you have a negative base and it's raised to an odd power, that is going to be a negative answer. Something to keep in mind as we're going through these. It's an important part of this one. Okay, so today we're going to learn about the multiplication rule. So let's start by looking at this example. We have x to the third power times x to the fifth power. So let's write that out and expand it. So that is the same as saying x times 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 x. Where here there are 3 x's and here there are 5 x's. When we have 3 x's and we have 5 x's, we multiply those 8 times. So all together we have 8 x's. So this is x raised to the 8th power. What do you notice about these exponents and this power right here? So what do you notice about this power, and this power? You should notice that these two powers, when added together, are equal to 8, which is the same as this power over here. What you should have noticed is we have x to the third plus 5, which is equal to x to the 8th. And we can generalize this to other numbers, which means that we can put this into meaning for other problems. The general rule we're looking at here is x to the m power, so however many times x to the n power, however many times n, is equal to x to the n plus n. So I'd like you to go ahead and take a minute and pause, and you're going to try exercises 1 through 4 on your own. When you're finished, unpause the video and continue. Now that you have done those on your own, let's try and look at some of these together. Let's look at this first exercise 1. We had 14 to the 23rd power plus 8 power is equal to 14 to the 31st power. I do not expect you to multiply that out. This one we had negative 72, which needs to stay inside the parentheses because it's a negative base. And we have 10 plus 23 in the power, which gives us negative 72 to the 33rd power. Again, do not multiply it out. This one is 5 to the 94th plus 78. And we're just going to leave it just like that. On this one, we have our negative 3 inside the parentheses to the 9 plus 5 power, which is equal to negative 3 to the 14th power. You should notice that this answer would be negative because we have a negative base to an odd power. And this answer has a negative base raised to an even power. So you're going to have a positive answer. These other items are positive bases raised to positive powers, so they will have a positive answer. Let's go a little bit deeper and try some more things. So let's use a different variable. Here we have a to the 23rd and a to the 8th. They're multiplied, showing this little dot. They're multiplied to each other. So we're going to say a to the 23rd power plus 8 powers, which is going to equal a to the 31st power. in this one, exercise 6, we have f to the 10th power times f to the 13th power. We could write that out, 10 f's and 13 f's, but when we multiply them all together, we would get f to the 10 plus 13, which is equal to f to the 23rd power. You should be writing all of this down in your notebook. So we have here another b, so a different variable, b to the 94th power. We're going to add the powers because they're multiplied together, plus 78. And we're just going to leave it just like that because that's a really big number. Okay, let's look at our last one. It says, let x be a positive integer. So we're going to pretend this is a positive number. Well, if we have -3 to the 9th power, we're going to put parentheses around that. And then we know that that's plus some x value, because these two are multiplied together, is going to be equal to -3 to the 14th power. So we need to think, what number plus 9 is equal to 14? Well, I know that if I put a 5 in here, 9 plus 5 is going to be 14. So the x value we're looking for is actually going to be 5, because this would make it 9 plus 5 is equal to 14. And we know that they're added together because these two bases are multiplied together. Let's try another one. We have 9 times itself 4 times. And then another group of 9 times itself 6 times. And then another group of 9 times itself 13 times. And these are all multiplied together. So what do you think we're going to do? We have a group of 4, a group of 6, and a group of 13. They're all multiplied together. So we follow the same rules. We add each of the exponents together. So 6 plus 4 is 10. Plus another 13 gives us 23. So the final answer here would be 9 to the 23rd power. Same thing here. We can just add all of our exponents together because they have the same base and they're all multiplied to each other. We can write this out in expanded form if you'd like, but I think at this point you know that we just add the exponents together. So now we have 2 to the 3 plus 5 plus 7 plus 9. These two together are 8. These two together are 16. Finally, these two together are 24. So this answer is going to be 2 to the 24th power. Here's a few more that are very similar, except for this one we have 6s and 4s. The 6s and 4s are different bases, so we can't add their exponents. So what we're going to do is we're going to have two different sets here. So we're going to have one group of the 6s. So we'll have 6 to the 5th power plus 14 times, and we'll have a second group. The second group will be our 4s. We have 4 to the 9 plus 3 power. So in the end, this is going to give us, let's do purple, shall we? 6 to the 19th power times 4 to the 12th power, and that's as far as we can go without multiplying it out. So we're going to do the same thing here. I'm going to box out the negative 4s. And we can circle the 17s. So on one hand, we're going to put these two together, and then we'll put these two together. So we would have a -4 to the 3 plus 2 power, because the powers are 3 and 2. And multiplied by 17 to the 5 plus 7 power, because the 17s have powers of 5 and 7. And that is going to equal -4 to the 5th power times 17 to the 12th power. Finally, we have number 13. We should recognize that we have two different bases. We have 15s, which I'm going to put a box around, and I'm going to circle the 7s. What's different about this 15 here is that it doesn't have a power, but there's always a 1 If it's by itself, there's always a 1 power because 15 to the first power is just 15. So we have 15 to the 2 plus 1 power times 7 to the 4 plus 2 power. That's going to give us 15 to the third power times 7 to the 6th power. That's going to give you a pretty good idea of some more exercises that you could do. For a challenge, you can complete problems 14 through 16. Exercise 17 comes after finishing or skipping the challenge. We're going to rewrite this expression. So let's write it out completely. And I think if we write it out completely, it's really going to help us see what's going on here. So we have a 2. And then how many x's do we have? We have 3 x's. So we have x, x, and x. And we're multiplying that by 17. And here we have 7 x's. So x, 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 x. So that is 7 x's. So when we look at together, we have a 2 times 17, and then we have 3 x's here, and here we have 7 x's. So we have actually x to the 7 plus 3, so that is x to the 10th power. And 2 times 17 is 34. So we have 34 x to the 10th power. These coefficients, or the numbers that are in front of those x's, those can be multiplied by each other. The only thing that tells us how many x's we are going to write out is the exponents. So the answer to this problem is 34 x to the 10th power. Let's go ahead and try another one. Remember, the distributive property is going to tell us that we're going to multiply a to a and a to b as well. So when we multiply this out, we're going to get a times a plus a times b. If we have to write this in simplest form, we would write a squared plus ab. We can't combine these two because they don't have the same bases. Let's try one more. We're going to use the distributive property to distribute the b to the a and to the b. So we have b times a plus b times b. This leaves us b times a plus b squared, because b times b is b squared. We cannot combine these two terms because they are not the exact same bases. Okay, so that's all about the multiplication, and now we're going to move on to some division rules. So let's think about division in this way. Let's list them out like we did before. So this is equal to 6 x's over 4 x's, and I'm going to put them right underneath so I can show you what's going on. Remember that when we have x's, an x over an x is just a 1. So these two x's cancel each other out, these cancel each other out, these cancel each other out, and these cancel each other out, leaving us with just 2 x's, which is the same as x to the 2nd power. But when we see here, what we should see is that we have 6 on the top and 4 on the bottom. And how is that related to the 2? Well, I noticed that I have x, and then I have 6 minus 4, which gives me x to the 2 power. So when we have two exponents that look like a fraction, that's actually a division sign, because this here means divide. When we have two bases that are on the top and the bottom of a fraction or in a division problem, we're going to subtract the bottom from the top. So here we have 6 minus 4 is 2. So we can generally make that a rule by saying whatever we have on the top is x to the n power, on the bottom is x to the n power. We have x to the top number minus the bottom number is going to help us make that rule. So let's go ahead and have you practice some. I'd like you to practice exercises 21 through 24 and then come back and unpause the video when you're done. Now that you've finished those, let's go ahead and check them. So we're going to have 7 to the 9th power minus 6, which is going to be 7 to the 3rd power. We're going to subtract top minus bottom. Okay, on 22, we're going to remember to put the negative base inside the parentheses, and then we have 16 minus 7, which is negative 5 inside the parentheses to the 9th power. On 23, it's a fraction. It feels confusing, but it's the same thing. We just say 8/5. We put it in these big old parentheses so that it's wrapped together, and it's to the 9 minus 2 power, which is 8/5 to the 7th power. Here we have 13, and it's 5 and 4, so we have 13, and we have 5 minus 4, which is equal to 13 to the 1st power. And remember that anything raised to the 1st power is just itself, so this would just end up being 13. Here we have another one that feels a little tricky, again, because it has fractions, but don't worry, a fraction in this case is just like anything else. We leave it inside the parentheses. This is a over b. And then we look at the exponents. We had 9 minus 2, so this is going to be a over b raised to the 7th power. Here we go, we can do this one again, just like before. We have x to the 5 minus 4 power, which is x to the 1st power, and we can remember that anything raised to the 1st power is itself, so this one is just going to be x. Let's go ahead and try some of these a little bit harder, trickier ones together. So this 4 to the 2nd power is 4 times 4, which is 16. Well, 4 times 4, which is 16, is the same as saying 2 times 2, which is 8. Sorry, 2 times 2, which is 4, times 2, which is 8, times 2, which is 16. So these two are equivalent. If we change them into this form, it makes it easier to apply our division rule. So now we have 2 to the 7th power minus 4 is equal to 2 to the 3rd power. Moving on to 28, we find that we have 27 here. Well, 27, if we have 3 times 3, which is 3 squared, which is 9. When we multiply it by another 3, we do get 27. So that would be 3 times 3 times 3, which happens to be 3 to the power of 3. So if we put that into the denominator, that gives us 3 to the 23rd power minus 3, which gives us 3 to the 20th power. Moving on to 29, this is nice and simple. These guys are lined up, so just like when we did the multiplication and we dealt with each base that was the same individually, we're going to do the same thing here. So we have 3 to the 5th minus 2, and that's going to be multiplied by 2 to the 8 minus 3, giving us 3 to the 3rd times 2 to the 5th power. We just took each of these separately, and they're multiplied together, and we solve them separately. Again, same thing here, separate bases. So we're going to say negative 2 in their parentheses to the 7 minus 5 times, because there is a multiplication symbol in there, 95 to the 5 minus 4. That's going to give us negative 2 to the 2nd power times 95 to the 1st power, which you can just leave as 95. In 31, we have some very similar things, except for now it seems like we have both division and multiplication. So remember that we can just draw a 1 underneath there, and that's going to make it look like a fraction. So let's take this one out to the front here, and we'll say 5 over x to the 3rd power times 3 times 8 to the 8th power over 1. Anything that's a whole number, you can always put 1 underneath it, and that makes it look like a fraction. So if we write that out, we have 5 times 3 times 8 to the 8th over x to the 3rd. Well, we should see that these two, there's nothing that we can do with them except for multiply them together. So that's going to equal 15. And then we have x to the 8 minus 3, because we applied our division rule right here, which is going to give us 15 x to the 5th power. On b, we're going to do the same thing by putting this over 1 to make it a fraction. So we'll say 5 over x to the 3rd power times negative 4x to the 6th power all over 1. If we multiply it out or expand it out, we have 5 times negative 4 times x to the 6th power all over x to the 3rd power. So when we multiply these two together, we're going to get negative 20. So we're going to say negative 20 times x to the 6 minus 3 power. This negative 20 is not included in this x. So the only thing that matters in the power is the 6 minus 3. That's going to give us negative 20 times x to the 3rd power. And finally on C, we're going to do the same thing. We're going to put this over 1 so that it makes it look more like a fraction. We have 5x to the 3rd power times 11x to the 4th power over 1. We can write that more expanded out. So 5 times 11 times x to the 4th. We can multiply those together on the top, and we have x to the 3rd on the bottom because x to the 3rd times 1 is just x to the 3rd. So we know that these two, when we multiply them together, we're going to get 55. So that's going to equal 55 times x to the 4 minus 3, which is 55 times x to the 1st. We know that x to the 1st is just x, so we can write that as 55 times x. Finally, I want to show you something that you might see in a calculator that's a little bit tricky. She put these numbers into the calculator, supergiant numbers, and it spit out this answer here. What I want you to know is that means that is 4 followed by 21 zeros. So I don't know if I can fit them all on the screen. I think that did it. Oh, one more set. 1, 2, 3. So that's that giant number. And for now, you just need to know that this here is what you see, and that means 4 and 21 zeros after it. And we'll get a little bit farther into that when we get into a scientific notation, but that's as far as that one's going to go. So this ends our lessons. Now I want you to go ahead and think about what we learned, summarize it, write your question, and reflect by responding to 2 other people. Then you're going to do the homework on page S10. We're going to do problems 2 through 5. We're going to go over number 1 in class. So if you weren't in class today, you can skip it, but if you were in class, you should do number 1 and then finish 2 through 5 for homework and turn it on Canvas. Finally, you're going to do your exit slip. I want you to try and get it passed at 100% by taking 2 tries. If you have questions, you can email me or you can come see me for help.